This is the TBM 930. It has a Pratt & Whitney turboprop engine with 850 horsepower, giving it a service ceiling of 31,000 feet. It can reach cruise speeds in excess of 330 knots and has a range of over 1,700 nautical miles. First thing we're going to do is start the engine. I'm just using the default checklist in the menu on Flight Simulator. First thing we're going to do is ignition to auto, auxiliary boost pump to on. Next, we need to make sure the area is clear before we start the engine. And we'll check the items off as we go, but for the next few items, we're not going to be able to check them off as we go. We're going to have to read them and then do them and then go back and check them. We're now ready to start. To engage the starter, we're going to press it to on position, hold it for 2 seconds, then let go. Once we hit the starter, we're looking for a gas generator speed of 13%. Once we see 13%, we're going to take the throttle to low idle. During the start, we're going to start at NG and we're going to work our way straight down. After we introduce fuel, the next thing we're going to look at is ITT. The ITT limit is 870 degrees for 20 seconds or 1,000 degrees for 5 seconds. Around 50% NG, we can move the throttle from high idle over to the taxi position. We're beyond 30% NG by 30 seconds. You can see the timer over on the right. And also we need to be 50% before 60 seconds. You can see we're at 40 seconds right now and we're at 60% NG, so that condition's been met. We also need to check the oil pressure and the oil temperature and then make sure the automatic starter disengaged at 52%. And we know the starter disengaged, the white starter cast message is no longer displayed. So to reiterate, when starting a turbine engine, your eyes are going to be up here at NG, 13%, bring the throttle to low idle. The next thing you're going to look at is ITT and work your way down until the completion of the start. Next we'll go over the exterior lights. So you can see the taxi lights are dim but a wider angle. The landing lights are a narrower angle but brighter. The TBM 930 also has a pulse position. It looks like this. It's so other aircraft can see you more easily. We also have navigation lights, green light on the right wing, red light on the left wing, and a white light on the tail. The third switch on the panel is the anti-collision lights. You can see those flashing here. Backlit panel lighting can be controlled with this rheostat here. One direction makes it brighter, one's dimmer, and all the way to off. Next, we have a dimmer switch. You can turn that off and on. All that does is dim the landing gear lights. Cabin light switch turns these lights on in the back. The access lights look like this. They're used to get in and out of the airplane. Next is the electrical power section. The TBM has two 28 volt generators, a main and a standby. These switches up here are used to reset the generator if it goes offline. If we were using an external power cart for power, we would select GPU on the source switch and we would see 28 volts on the voltage indicator. Without an external power source with the battery switch and battery, we would see 24 volts. But in this case, we have the generator on, so we're actually going to see 28 volts, or in the Microsoft Flight Simulator world, we're going to see 29. So for this example, we'll turn the generator to off. The battery is still on. We can see the voltage is 23. We have a low voltage message and a main generator message, meaning the main generator is offline. For engine starting, we have two switches, a starter and an ignition. Starter and the generator are actually the same piece of equipment. When we move the starter to the on position, the starter is engaged, off position, nothing, and the abort position disengages the starter. The starter switch normally sits in the off position. If it were in the on position and the source switch was moved to battery, the starter would engage and the engine would try to start. That is not something you want. Next, we have the ignition switch. Ignition in auto makes the igniters work during engine start. In on, it works continuously, and in off, the igniter's turned off. You would select the on position during turbulence or heavy rain. Believe it or not, rain and wind are two things that can put a fire out. So if we have that igniter on, that's going to help keep the fire burning in the combustion chamber and help keep our engine running. And in case you're wondering what an igniter sounds like, it sounds like this. The TBM holds 301 gallons, but only 292 gallons are usable. The auxiliary boost pump is an electric pump. When it's selected on, we get the aux boost pump cast message. In auto, the boost pump comes on for low fuel pressure. On is continuous, which is also used during engine start, and the off position simply keeps the pump from running. The fuel selector switch has a manual and auto position. In manual, we have to switch between left and right tanks on our own. We can do that by selecting the left or right position, or we can press the shift button, and that will also switch between left and right. Normally the fuel selector switch is left in the auto position, and this is one of the coolest features of this airplane that they actually duplicated in the sim. With the fuel selector in the auto position, the selector will switch between tanks every 2 minutes and 30 seconds. In flight, the time changes, and instead of 2.5 minutes, it's every 5 minutes the selector will switch back and forth. And while this is going, one thing to consider if you're taking off and you have a fuel imbalance, always start on the wing that's heaviest. You can select it manually or press the shift button to the heavier wing. Placing the autopilot trim switch in the on position allows your autopilot and trim to work. The autopilot off position prevents your autopilot from working, but your electric trims still work. In the off position prevents the autopilot and electric trims from working. The ELT helps locate a crashed airplane. Place it into the on position activates the system. The red light means the ELT is transmitting. Hold the switch in the test position for 1 second and you should see the red light come on. Next we have the environmental controls. We have air conditioner for the pilot passengers, and then we can turn the air conditioner off. Then there's a fan speed and a temperature control. In Flight Simulator, they do absolutely nothing. Below environmental controls, we have CB or circuit breaker light. That turns on the light for the circuit breaker panel over on the right side. You can see it flashing on and off. And next, we have the de-ice system panel. The first switch is the de-ice system for airframe. This just blows the boots on the wings and the tail. The system cycles by itself. Turn the switch on and leave it on. When you exit icing, turn it off. The de-ice light is here. You can see that just below the pilot's window. That shines on the leading edge of the wing so you can see ice at nighttime. Next we have prop de-ice. That's electrically heated panels on the inboard section of the propeller, as you can see here. You'll also know the heated section's only on the inboard part of the propeller blade. The part beyond that spins so fast that the ice can't stick to it. Next we have the windshield heat. The front two windows are electrically heated. Windshield heat switch can stay on in icing conditions. If the windshield gets too hot, it will automatically turn off. If the windshield cools back down, it will apply electrical power and heat the windshield back up. You also notice we have pitot heat left and right, also on the right side. In addition to the pitot heat, it also heats the stall vane. The inertial separator opens two valves. This prevents heavier objects like debris or rain from going in and damaging your turbine blades inside your engine. The inertial separator would be turned on during taxi, landing, and in flight when in icing conditions or in heavy rain. The landing gear is electro-hydraulically actuated. The check down button is just another way to check to make sure that the gear is down. It uses a separate electrical circuit to check the position of the down locks. If the gear is down, the lights will flash at a faster rate. The light test button is nothing more than a light bulb test. Hot airflow directs more air to the windshield for defogging or more air to the floor. The emergency ram air valve opens a valve. It's used to help clear smoke. It can also be used to help depressurize the airplane in an event of a pressurization failure. In the alternate static source, if your primary static source ices up, you can pull this and alternate static air will be pulled from the tail of the airplane to run your static instruments. The flaps are electrically operated. There's 3 positions, 0, 10, and 34 degrees. Takeoff flaps or 10 degrees of flap can be used up to 178 knots. Full flaps, you have to be below 122 knots. The throttle has 2 sides. The right side is for high and low idle, which also puts the propeller into the feather position. The left side is for normal operation from taxi to full power to reverse thrust. The manual override is used if the throttle fails or if the fuel control unit fails. This lever is much less precise than the throttle, but does give a backup alternate in case of failure. Next is the aileron trim. It moves 10 degrees left and right. This is full right, and this is full left. You can see the trim tab is deflected down. Elevator trim can be used electrically or manually by moving the trim wheel like this. To operate the trim electrically, you need to have the yoke up and you move the switch forward or aft. Rudder trim is also on the yoke. You can move it left and right like this. And you can look up here to see which way the airplane needs to be trimmed, left or right. If the line is on the left side of the triangle, you need left trim. If it's to the right, you need right trim. And you can look over here to see your trim position indicators. So we now have full left rudder trim, and we can go outside and see what that looks like. And it looks like that. You can see the trim tab off to the left. The parking brake can be operated with this knob. It can also be turned off by pressing Control period on the keyboard. This is the mic oxygen mask switch. It doesn't do anything in Flight Simulator. In real life, this button would switch your microphone source from your headset to the oxygen mask. There are 2 oxygen switches. One turns the oxygen system on. The top switch will actually deploy the masks manually. They'll drop down in the back from these red panels. If you didn't use that switch, they would drop down between 13 and 14,000 feet cabin altitude. But the sim is not modeled for that, so they actually do not do anything. The pressurization system is very similar to a balloon. Think of the air being blown into a balloon, and then a small hole at the back of the balloon, letting air out, regulating the pressure inside the balloon. That's essentially how the pressurization system works. Air is pumped into the cabin from bleed air off the engine, and air is regulated exiting the airplane through an outflow valve. There are 3 main cabin pressurization indications. The cabin altitude simply tells us the altitude inside the cabin. The rate tells us how fast the cabin is climbing or descending. And when the airplane is pressurized, the cabin altitude and cabin rate will not match what the airplane is actually doing. If you depressurize the airplane, they will match what the airplane's doing. The differential PSI or differential pressure is just the difference in pressure from inside the cabin versus outside the cabin. The current differential is 6 PSI. What that means is for every 1 square inch, there's 6 pounds of pressure pushing out on the airplane. The bleed switch controls the air coming into the cabin. The auto position has a slower rate of change and provides an increase in passenger comfort. The max diff position or maximum differential will increase the differential to the maximum and provide a lower cabin altitude. The off position closes the bleed valve. It does not work correctly in Flight Sim 2020. With that switch off, the cabin should start to climb or depressurize. The dump valve sits in the norm position. If you push it, the dump light illuminates, and that opens the outflow valve, dumping the air out of the cabin. That's used to help clear smoke. I've slowed this next part down so you can see what happens when we press the dump valve. First thing we'll notice is the cabin rate increases. We're now climbing at 150,000 feet per minute. That might be a little bit extreme, but it is fast. The cabin altitude will also climb. You can see it going up, and it's going to go on up past 10,000 feet. If we leave the dump valve open, that altitude's eventually going to match the airplane's altitude. The differential will also decrease. If we were to leave the dump valve open, the differential would eventually go to 0 as the airplane altitude matches the cabin altitude. The dump switch is now in the normal position. The outflow valve is working correctly. It's no longer being forced open. We can see the cabin rate is descending the cabin at 499 feet per minute, and it's now pressurizing the airplane again. As the altitude lowers, the differential pressure will increase. Now that we've covered almost every single button and switch on the panel, the last thing is the flight director control panel, also known as the autopilot. The heading knob can be rotated to fly a specific heading, or you can push it to fly the heading you're currently on. But the autopilot will only fly the heading if the heading button is selected. And I'm jumping around a little bit, but you can push the baro knob to get standard 2992, or you can rotate it to set the barometric pressure. To use the nav mode button, we need to have a VOR up or a destination in the GPS. So we'll put a destination, KHUF, Terre Haute, Indiana, and we'll fly through that using nav. There's our destination, the line shows up, press nav, and nothing happens. There's a reason for that. It says heading in VOR. It's in VOR mode. We need to change the CDI to FMS mode. Now that we've done that, we see a magenta needle and we see FMS on the flight mode annunciator in green. Next we have the FD button, or flight director button. That can be pressed to turn the flight director on and off. I currently have it turned off. Next is bank mode. This is half bank. It limits the bank to about 15 degrees. This would be used at slow air speeds or high altitudes. Next is the transfer button. This is going to transfer the autopilot to the co-pilot side and use information off the co-pilot's primary flight display. This would be used if the left primary flight display fails or if the right seat pilot is flying. Next is the AP or autopilot switch. You can press any mode on the flight director control panel. Nothing will happen unless you press the autopilot button. Once that's pressed, the airplane will turn, climb, or do whatever you've told it to do. The yaw damper just uses the rudder to help reduce yawing and rolling motions. If you press the altitude button, that will just hold the aircraft's current altitude. So currently, altitude is being held. We're going to dial in a new altitude. And when we do that, we have to press vertical speed to get the airplane to descend. So basically, you're dialing in an altitude and then telling it how you want it to get there and at what rate. Vertical speed is adjusted by moving this wheel up and down, and when you selected rate, you can see over on the left here what the rate actually is. The speed button does not control speed directly. This changes the units from indicated airspeed to Mach. This would be used with flight level change. Flight level change will simply climb at an indicated airspeed instead of a vertical speed. You can climb with vertical speed. It's perfectly okay as long as you're paying attention. The only thing with vertical speed, the airplane's going to try and maintain the rate despite the airspeed. It might get so slow that the airplane could stall. Flight level change should not let that happen. It's going to maintain the airspeed that you tell it. To show that, I've sped up the film, I've put in a climb, and you can see the airspeed decreasing while the vertical speed stays the same. Now I've selected flight level change. You can see where it says flight level change on the flight mode annunciator along with the speed. We'll dial the speed to 160 knots. The airplane will pitch down until it gets to 160 knots. Then it will adjust pitch to hold that speed. And the speed at which it climbs at can be adjusted the same way you adjust the vertical speed. Just move this wheel up and down, then look over at the speed to see what it's set at. And once your altitude is set, if you're climbing in vertical speed or flight level change, you do not need to press the altitude button to get the airplane to level off. It will level off automatically at whatever you have set in the window here. The nav mode will fly GPS, VOR, or a localizer. It will only fly whichever one you have selected in the active nav source. In this case, we have a localizer tuned and we have a green loc on the flight mode annunciator. We're now on the same ILS approach, just about ready to intercept the glide slope. I've pressed approach. When I press approach, I get a white GS or glide slope armed light on the flight mode annunciator panel. When the glide slope centers, the GS will move up to where alt is and turn green. When approach is selected, the last altitude will be held until the glide slope centers. Now that the glide slope is captured, it turns green. The glide slope is going to be followed all the way down to the runway. The only mode I haven't talked about yet is the BC or back course button. That's used on a localizer back course. Normally you use nav on a non-precision approach where no altitude will be held, but on a localizer back course you do not use nav, you use the BC back course button. And I do plan to do a localizer back course tutorial in the near future. Remember, if you press a button on the flight mode annunciator, you will see a corresponding message on the flight mode annunciator. The last step is the engine shutdown. To shut down the engine, set the parking brake. Next, we're going to turn off exterior and interior lights. Place the fuel selector to the manual position, and also turn the autopilot trim switch to off. Next, we'll turn the bleed valve to off. We don't want to open the door or try to open the door with a pressurized airplane. Next, we'll move the throttle to the flight idle position for 2 minutes. And the whole point of going to flight idle for 2 minutes is to attain the lowest possible ITT. Then after going to low idle for 15 seconds, pull the throttle to cutoff. After cutoff, inertial separator needs to come off. It takes about 30 seconds for the vanes to fully retract. Then we'll turn the boost pump to off. Next we'll turn the generator to off. And if the inertial separator is retracted, there's no lights, the message is off. We can turn the source to off. And if you notice the propeller blade, that's what the feathered position looks like. The low pitch or high speed position, the blade would look flat. You would see the whole back of the blade in front of you. And as I said, if we can turn the source switch off, we can just move the crash bar all the way down. That'll make sure the source switch and the generator are both turned off. Thank you to everybody watching. Thank you for making it this far if you did. If you have any suggestions on future videos, please feel free to comment. Thank you.